So triangle similarity conditions. Can you guys find that in your packets real quick? You got a learning log that says triangle similarity conditions. We learned 2 of these last week. Do you remember what those 2 were? AA was one of them. AA similarity was one of them. And SAS was another. And let's get some examples down for each of these. These only work with triangles, right? So let's draw a couple triangles here for AA. We're talking about similarity here, so they don't have to be the same size. Remember, similar triangles would have the same shape, not necessarily the same size. And AA just means that I have 2 pairs of angles. So I need to mark an angle on this triangle with a matching angle over here. It doesn't really matter which one it is, as long as we've got, and that's only 1 pair of matching angles. I need a second pair, so let's go ahead and make a second pair here. Yeah, pick another one. That right there is enough for me to know that those 2 triangles are similar. We don't have to have a mark. Sometimes they'll do it. Well, they'll give you actual angles. They'll say this is 55 and this is also 55. We saw some of those in our homework. All right, SAS. When we wrote this in our notes, we wrote ourselves a little note about SAS in the order. What has to be true when we're looking at our 2 angles with SAS? What's got to be true about that angle? Anthony, do you remember? Angle has to, can't spell today, has to connect the 2 sides. I like that wording a lot. I'm going to use that exactly. Angle has to connect. I'm going to modify it slightly. I'm going to say both sides. So let's say I had this angle up here. Let's say I knew this was 50 degrees and this was also 50 degrees. And then I would need sides on both sides of both of these angles, and they've got to be in proportion. So if, let's say I went 3 and 4 here, give me 2 numbers that would work here and here that could be in proportion with 3 and 4. 6 and 8 could work, right? Those would be in proportion with 3 and 4. Because I could do 6 over 3 and get 2. I could do 8 over 4 and also get 2. So this would be SAS. But the angle has to connect both of those sides. See that 50-degree angle was touching both of the sides that I had info on, and same thing over here. I want to give you one more similarity condition. Question first. So the question is, are the numbers backwards? Do you want the 8 to be here and the 6 to be here? That would also work. Yeah. It doesn't matter. As long as the sides are both touching the angle, right? As long as the sides are both touching the angle, and I can make a, or I can show that they're in proportion. So I can make 2 fractions that are the same. So in this case, I would match up. I wouldn't match up the 8 with the 3 because the 8's the bigger one here. 4 is the bigger one. I match the 8 with the 4. So I go 8 over 4. Doesn't matter where they're located because we do it based on their size, right? Bigger one over the bigger one, smaller one over the smaller one. So 8 over 4 is 2, 6 over 3 is 2. I've got the same ratio for both of them. Yeah. So it doesn't matter where they are in the triangle as long as they're on either side of the angle. And as long as when you match them up by size, you get the same ratio. Great question. Thank you for that. Other questions on these two before we go on to our third one? All right, last one. Anybody know what the third one is? Anybody want to guess? ASA is a wonderful guess. And I love that you said that, but I would point out that if I had two A's, I wouldn't need the S. Right? So SS is close. SSS. SSS. Someone said SSA. We'll talk about that in just a second. SSS is the other one. But I'm glad you said ASA. Now, we will use ASA when we get to triangle congruence. And you may have done triangle congruence already? Okay, so that's where you're knowing that from. But do you see what I'm saying? If I had ASA, I really wouldn't even need the sides because the two A's, the two angles would be enough for me to do it. So that's why we don't do ASA for similarity. It's more than we need. We're already covered by angle. So SSS, let's give ourselves an example here. And I'm just making up some numbers here. I'm going to go 10, 11, 12 for this triangle. And then I'm going to go 30. 30, what's my scale factor here? 3, so 11 times 3 is 33 and 36. So SSS similarity, we could write three fractions. 30 over 10 equals 3, 33 over 11 equals 3, and 36 over 12 equals 3. So we don't need any angles at all, but if we don't have any angles, then we need all three of the sides. All right, now there are two that do not work that we want to stay away from. I want to put these in red. These don't work. And that is ASS and SSA, which is basically the same thing. And they just don't work. We can't use them because they don't work. Not because it spells it bad. It's because they don't actually work. I've got an example I can show you. Bless you. So I'm going to say this is 5. And this is a 45-degree angle. And this is 4. If I had that, that would not be SAS, correct? You see how the angle is not touching both of the sides? It's only touching one of them. Now, for those of you who are really strong visual thinkers, I want you to imagine that I take this 4 and I swing it over this way to get it to match up with the bottom of that triangle. What you would end up seeing, you would still have your 5 and your 45. That's not changing. But that 4 would actually work right here as well. So those triangles have ASS or SSA, but they are clearly not the same shape, right? You get how that works? This kind of swings over. It ends up over there. So that's an example of why we cannot do it. So SSA, ASS, we stay away from. Okay, that's it. Let's practice a little bit of these. This is going to be on page 178. We're going to practice with some flowcharts. You guys did really, really well with this the other day. You got this, Dan. You got this. You ever hear the phrase "fake it till you make it"? Yeah. It means you put a smile on your face, even though you don't feel it. You put a smile on your face, and then eventually you end up happy. Doesn't work 100% of the time. All right, we are going to work with these two triangles in part A, but I'm going to do a little bit of fancy footwork and spin them so they're both facing the same direction. I'm going to draw the first triangle just as it looks in the book. But the second triangle I'm going to spin so it looks exactly the same. So it's a little bit bigger, but I'm going to keep my angles so they look like that. I'm going to have to be careful when I copy it down because the letters have all moved around now. Double tick mark was E. Single tick mark was D. No ticks was F. Between D and E, we had 42. Between E and F, we had 38. All right, so I want us to think through our three possibilities: angle, angle, side, and side, and decide which of those we could potentially be using here to prove that these two triangles are similar. Angle, angle possibility? Yes, absolutely, right? We got two pairs of angles. Could we do side, angle, side? This triangle has side, angle, side, doesn't it? Does this triangle also have side, angle, side? No, it doesn't. Since they don't both have side, angle, side, we can't use it. So it looks like we're stuck with angle, angle. Awesome. Let's write ourselves a flowchart proof. All right. I'm going to write one of my evidence bubbles. Which two angles match up? A and D. A is congruent to D. Angle A is congruent to angle D. Copy that bubble down and then see if you can write me the other evidence bubble right next to it. I'll give you a hint. It's also going to be some angles. Listen, you need some paper? You don't have any paper? There's a whole stack of it over there. And a lot of it, if you look, it's all extra copy stuff on the same book where the books are, but I copied stuff with graph paper on the back. So just look at the flip side of whatever is there and find a couple that have graph paper. Yeah, there should be a bunch of stuff with graph paper on the back of it. Just grab a few of those. It doesn't all have graph paper on the back, but some of it does. I don't know what happened to my stick. I got some blank paper here too. Huh? This is all written on one side. I just use it as scratch paper for the back. All right, what's my other pair of congruent angles? E and B. Or B and E, either way. All right, and that's it. That's all the evidence we need to prove the triangle similar. So let's read our triangle similarity statement. I'm going to go triangle ABC is similar to triangle. And since we've taken the time already to rotate that second triangle so that it matches, it's going to be pretty easy for us to match this up in the right order. ABC goes with DEF. That's our conclusion bubble. And we have to draw arrows. And we need to make sure the arrow goes from the evidence into the conclusion. So from the evidence into the conclusion. And one last thing, let's write our reason below and to the right of this bubble. Our reason for this was, which of those three conditions did we use? A similarity. Make sure you put the similarity mark after it. All right, how are we feeling? I'm gonna do one more with you together, and then I'm gonna ask you to do a couple on your own. Actually, I'm just gonna get you started on part B. You're gonna do most of it on your own. Sorry, I kind of lied. I'm gonna go ahead and draw the first triangle as it looks, kind of like we did a second ago. Ooh, this is a right triangle. And then I'm going to draw the other triangle so that it's also with the right angle down on the bottom left. And my longer side is here. My longer side was 12. And this is 9. Oh, yeah, we want our letters too. Thank you. HIG for the first one. And my right angle was L. On the other side of the 9 was K. And on the other side of the L, or the 12 was J. So since we've taken a little bit of time at the beginning to rotate them and make them facing in the same direction, it's going to be a lot easier to write our similarity statement at the end. Which of our three reasons could we use this time? Could we use SAS? We could. Now, I want to pause for a minute because I want to take this opportunity to practice something else. Because we could actually use SSS as long as we could figure out what this side was. And you are going to be tested on this on Monday. So let's go and practice it right now. What could we use to figure out the length of this side? If I gave you just that triangle, you should be able to tell me the length of that side. And the tool is, we should be able to use Pythagorean theorem. So let's take a moment right now and practice our Pythagorean theorem skills and find the length of this side. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. And this is the one needs to go over here because that's hypotenuse. Do you guys want to just call it C? Let's call it C. And the 12 and the 9 are legs, so those will go over here. 12 squared is 144. 9 squared is 81. And 144 plus 81 is 255. And how do we get the square off of the C? Square root on both sides. What is the square root of 255? 225, thank you. What is the square root of 225? 15? Exactly 15, right? All right, 15. All right, now could we do SSS? Let's practice SSS, okay? Now these ones, with the S's, we got to write out a little bit more. Let me write my first evidence bubble here. I'm going to go with the 16 and the 12, but remember I have to do the name first. So I'm going to say HI over LJ equals 16 over 12 equals, and then I want to come out with a decimal for this. Comes out to about 1.3. It's 1.3 repeating. I'm going to say 1.33. That's good. That's my first evidence bubble. I need 2 more of those, and I'm really hopeful that the other 2 will also come up to 1.33. Can you guys go ahead and write me the other 2 and then finish this off? And then I'd like you to go on to parts C and D. All right, so you have some time here to work on your own. I want you to work through those, spy on your neighbor. If you need to, check in with your neighbor, make sure they're doing okay. Ask each other questions. Ask me and Mr. Schweitzer questions. We'll be wandering around helping you out with these, okay? I'm still waiting on a couple people. Thank you. Still waiting on a couple people. Just put your pencils down and look up here for a second, folks. When you get to part D, if you're looking at part D in your book, you notice how it's got 2 triangles that are overlapping. We're going to see this happen a lot in this class, and our general strategy is going to be to separate them, to draw them separately. Look at the screen right now and notice that I've got 2 triangles drawn separately. I want you to help me put some numbers in here. Now, I'm going to tell you that this is 9, and this is 5, and this is 11, because that was easy to see in the original picture. Can you look at your book, though, right now and tell me what number I need to put between B and M? Look in your book right now and tell me what I need between B and M. What am I going to see there? 11.5. Can you please look at your book and make sure you understand why I put an 11.5? Do you guys see where we're getting that from? In the book, it's got a 9 and a 2.5, and we just added those together, right? Don't miss this. Please look up here again. Folks, I know that I love that you're trying to get this done, but I need your attention. Don't miss this. When I drew these, they originally both came from a picture that had the same angle right here, right? So what does that mean about these 2 angles right here? They should be congruent. They came from the same thing. So when you get around to doing this, draw them separately and go ahead and mark those congruent. They came from the same place, which means we should be able to use which of our 3 rules to do it. Angle, angle. Now, when you finish with number 178 or 78, no, page 178, number 71, I'm going to ask you to go on to 72. Can you please look back with me at 71? Folks, please just pay attention for a couple seconds. Just stop writing and pay attention for a couple seconds, okay? When you get to 72, they're going to ask you to figure out how big BC was. BC came from 71 part A. Go back to your work from 71 part A and put an X where BC is. Do you think you would be able to write me an equation and solve for X now from that picture? That's what you're going to be doing in 72. If I were going to do it, I would go X over 38 equals 12 over 42. And then I would cross multiply and solve that to figure out what X is. Okay. So I need you to finish up 71 and 72. And when you're done with that, you're done with your classwork for today. It's time to move on to the homework. We got it? Please get our attention as you're continuing to do 71. If you have not gotten to part C, there is something kind of tricky about part C also. Just get our attention. We'll be happy to help you out. I'm going to go ahead and put the homework assignment up here. If you need any help, please get our attention. All right, get after it.